Saxon's Calculus, Lesson 89 is about balance points. Now, this is a lot more science, I feel, than it is math, although finding the point that they're looking for is purely using math. But the ins and outs of the science part, I don't fully grasp, but I grasp it enough that I think I can explain it to you. So if you have something and you need to balance it, you're usually going to put it in the center, unless, of course, there is something that is affecting or pulling on either side of it. And then if that's the case, you need to adjust or slide where that center of mass needs to be for it to be balanced. Okay, so they're saying if they put force on this side of it, then obviously they're tipping it this way, so this needs to go a little bit this way. And then in reverse, if they pull it on this side, then it needs to go more the other direction. Okay, then they start talking about the numbers. And basically what you need to take away is that you need to find where the average of your numbers are and subtract each of the given spots along your line, board, whatever it is you're dealing with, and then average them. Now, before I go that far, let me make sure I didn't skip something here. On the top of 436, it talks about a moment of force. All right, that is a part of their finding where, like if they're pushing on it with a 6, a 3, and a 7 at different places, then the moment of force is where those are combining. We must place the fulcrum at a point such that the sum of those, and they call those moments. The sum of those moments about any point on the board equals 0. And then they go through some of the math steps that they're trying to do on page 436 and 437. And on 437, they say, we see that when the fulcrum is properly placed, the sum of the moments about the fulcrum equals 0, and the upward force at the fulcrum does not cause an unbalanced moment. The directed distance from x to x is the x sub 1 minus the original x. And the directed distance between a second one, anyway, they do some more math there on page 437. And they finally go to a summarization on 438 where they tell you that a moment of mass is the moment of force divided by the acceleration of gravity. And that equals then m times x. So the equation for line x given above defines that for the gravitational system to be the sum of the individual moments of mass divided by the sum of the masses. Okay, so they do one example to try to now pull all of this together. Find the balance point for the system of masses suspended from a massless support as shown. So they're giving me a line. They are marking a 5 here, then a 6 here, 2 more, and then a 7 here. No, not a 7, goodness gracious, a 4. Okay, that's better. So what we want to do is find, and you have to label, I left these lines off, you have to label the starting point at here 0, 1, 2, 3, 4, 5, 6, 7, and 8. Did I miss a line when I did those? I did. I knew there was supposed to be 2 in between those. Try that again. 4, 5, 6, 7, 8, 9. That feels a little better. Okay. And they had given another line, which they then labeled 10. I just didn't have that extra line on there. So now, what does the 5 match up with? Well, that's the 3, so it's going to multiply with it. Add with, what does the 6 match up with? The 6. Add to, what does the 4 match up with? The 9. So we're going to add that all together. And then we are dividing by the sum of the numbers that are pulling. So that's the 5, the 6, and the 4. So when we work that out, we get 5.8, and that's just calculator work. So then they clarify, if I just say I'm 5.8 away from the origin, that it's unhelpful because I chose where to start with the 0. Because what if I had started numbering this 1, 2, 3, 4, 5, and then I used 11 here at the end? Well, my number should still come out close, but it's going to be different because I'm moving less places away from the starting place, which was 1, not 0. 0, I needed to move more, 5.8. So they say, let us clarify these numbers by being specific and saying that instead it is 0.2 units away from 6. And then to be even more specific, it should be less than, which is indicating to the left of, so 0.2 units left from the 6. Oh, the mass of 6 is their actual answer. But you get the idea there of what they want you to do. And you did this concept in trig class, so you should already be vaguely familiar with this numbering of this yourselves and then finding the basic average there.